Hi, everybody. I'm Steve, 0xWildhare on all my socials. I am going to talk to you today about, how awesome TLS Notary and the work that they have done is, and some of the other challenges you're going to come across if you're an app developer who wants to incorporate verified data into your application. This picture is unrelated. But I saw this guy across the street yesterday and took a picture, and I still don't know what those are, but it looks a little bit like my PFP, so maybe we're brothers. So now you guys also know that kangaroo donkeys are a thing. Let's start by just laying out the terminology I'm going to be using. So app developer, theoretically that's you. This talk is sort of geared for an app developer. You're building an app. Your app depends on some kind of verified data coming from a user and their account on a target platform. So the target platform could be a government website that has some sort of citizenship data on it. It could be a bank with financial information. It could be Uber with your transportation information, Grubhub with information about what you're eating. Whatever your app does, whatever verified data you need to bring into that app that exists on some other platform, your app's going to request that. The user and a notary, and we're going to get into in a little bit who that notary is or can be. You enter into a MPC session, and then a request is generated. That request needs to match what this target server is expecting, right? We send that, the weird little shaped arrow is because one of the neat properties is even though the MPC generates this request, it comes from the user's IP address. The target platform returns the information, and then the user has it. They can choose to send that to the application where it's ultimately verified. So, I think average app developer is just interested in the information, right? The developer wants the verified data. Can I have the data, please? And zkTLS answers yes, but it's a little complicated. So let's, sort of talk about the parts here. The notarization, this is what TLS Notary has essentially solved for us. I'm not going to talk a whole lot about that part. We've got the inputs going into the request. Like I said, the request has to be identical to what the target platform expects to get from their own app. Otherwise, they're not going to return the data that you want. And then there's a response that comes from that target platform, and that target platform is designed for that platform's app and their use case, not your use case. I took this right off the TLS Notary website. This should be familiar. Pretty much every talk today has used some version of this. Sort of like a pop quiz here. Let's go back over the terminology, right? The prover, that's the user. The server, that is our target platform. The notary is the notary, and the verifier is the app. Most app developers, probably, I think, they don't want to run the notary. They just want verified data. If you're an app developer and you want to run the notary on your back end, that simplifies a lot of things. That gives you cryptographic guarantees that the data that you're getting from that target platform is true. So there's some advantages to doing that, but it's also, some increased level of difficulty. So the easy answer, right, is a restaking network. If you're not running the notary yourself as the app developer, the next best solution is economic security as opposed to cryptographic security. And that's what restaking networks provide. there is a ton of capital that wants to provide services right now and not a ton of services for them to provide. So that economic security is very cheap, very abundant right now. Now I say easy, there's a lot that goes into building a restaking network. Myself and others have done talks on this. That is not the subject of today's talk. But personally, like if I'm your user, I'm much happier giving my data to a distributed network of validators who will never see unencrypted data than some large company that has every incentive to scrape and sell as much of my data as they can. So these target platforms, right, they could make this real simple for us and just sign their data. You know, if it's Grubhub, they could put a Grubhub signature on the data, and you could use that however you want. They're not going to do that. You could be building an app that's a Grubhub competitor, right? So that's not going to happen. The good news is we can just liberate the data. TLS Notary is permissionless. As long as you have the user's cooperation, you can get that data from that website or that target platform. They're not necessarily going to make that easy on us. Actually, sometimes they're going to make that really, really hard. If you want to read a really great blog about one instance of that being hard, this Pixel Melt blog is great. They bought an ebook on Amazon, but didn't want to use a Amazon ebook reader, and it just goes through the challenges of reverse engineering that API and actually processing that data into something usable. It's a great read. If you don't want to write that down right now, just hit me up after. I'll give you the URL. So I've said a couple times, right? The request going to the target platform, it has to be identical to what that target platform expects from their own app. Otherwise, it will be flagged as suspicious activity. They're going to cut you off. It's going to cause problems for your users. At a minimum, it'll be these pop-ups that you get about suspicious activity, or emails that you get suspicious activity on your account. So the reverse engineer that's figuring out how to formulate this request and get all the pieces of this puzzle in, they've got a difficult job. Please don't ask me too much about that. This is sort of like dark arts to me. I know the very basics, but it involves a lot of like sniffing traffic with specialized tools and jailbroken devices, et cetera. One thing I do have some experience with, they need burner accounts, and even just the act of creating burner accounts on many of these platforms, that's suspicious activity, right? The platforms don't want, they're fighting bots, they're fighting scammers, they're probably not aware of this type of activity yet, but if they were, in many cases, they'd put in efforts to prevent specifically this as well. So you got your work cut out for you creating the correct request. One problem that is already solved by TLS Notary, the request comes from the user's IP address, which is just great, right? Like if the request comes from AWS server, that's going to immediately get flagged as a bot, right? They're going to reject that. They're going to say, hey, suspicious activity. Or even if you're using residential IPs and they're getting repeated requests for the same account from different IPs in different places of the world, likely to get flagged, right? They know the tricks, and they want to prevent their users being taken advantage of, and they want to protect what they consider to be, their data. Another nice thing, notarized result delivered to the user's device. They can choose what to do with it. Simple redaction is baked in. talk about some of the limitations of that in a moment. And again, the notary has cryptographic guarantees. So if that's a restaker, and you're signing off that this, this piece of information came from this server, you have cryptographic guarantees that you're not going to get slashed. So bottom line is MPC is the best way to scale a zkTLS network. That response. Many times it includes a bunch of information you don't necessarily need. It will include sensitive user data, private data. It will frequently be very large. For example, the user or the Uber, just a simple profile request from Uber, the response includes the information about all of the nearby drivers. So it's absolutely huge and has a bunch of stuff in it that you probably don't want as an app developer. So I've been a little, I guess I've been using MPC TLS to describe what TLS Notary team has delivered. There's been some debate in the space of, is that ZK, is it not ZK? I think the prover never sees unencrypted data. That is zero knowledge. That fits the definition. But here I'm specifically talking about adding a ZK VM to process the response. So you have a hash commitment on the original response. You can put some transforms into the ZK VM so that we can omit all of the unnecessary data. Instead of redacting the data, you can just leave it out, right? As Thomas mentioned earlier, sometimes redaction, like if it's your sex, male, female, are different numbers of letters, so you can still leak data through the redaction. If it's completely omitted, then you don't have that problem. This also enables range proof, so I don't have to tell you how old I am. I can just prove that I'm over 18 or whatever. And we can make the result a very simple, usable format for the developer. This is sort of like the reverse engineering. It's going to be customized to each platform. Each platform is going to have its own reverse engineering on the input and its own transformations on the output. There'll be some, knob switches, range proofs, things you can set, but pretty much all custom. So in summary, the TLS Notary team did an amazing job. As developers, there's a whole new range of information available, whole new range of apps that can be built. There's still some hard parts. Right now, our solutions include a TE-based notary. We have reverse engineering available for many popular platforms, and some TEE-based transformations on so secured by TE, not CK, of the response data. Coming, soon TM, we've got what we've been calling internally the big enchilada, which is a restaking network-based notary network, and ZK transformation on all of the response data. So we're super excited to see what is going to be built with this technology. It should be a major unlock. Now there is way more data. All of the data is available for your app. So what are you going to build? Thank you. There's my information. Please contact me or talk to me after. Do we have time for questions? 30 seconds? 30 seconds for questions? Quick one. All right, thank you.